Good afternoon, everybody. I'm going to go over some of the practice problems you guys worked on for module week 28. So it'll be mostly about going to the answers. I'm going to go over some problems with the answers, and then I'm going to also include the document with the answers to the questions and also a Desmos link so you can look at how to solve most of the problems geometrically. If you can solve 3 or 4 of the problems geometrically, everything else becomes very simple because it's the same process. Okay? So, let's begin with removing this piece of yarn. There we go. So, this was, I believe, problem number 1. 3x minus 7 is equal to 3x plus 1. If I solve it algebraically, I remove 3x values from both sides, and I'm left with negative 7 equals positive 1. Well, we know they're not equal, and if they're not equal, that means there's no solution between these two expressions, right? Now, geometrically, what's that look like? Well, I rewrite that whole equation. I rewrite it as 2 independent equations. Y equals 3x minus 7, y equals 3x minus 1. And since they both equal the same output, which was represented by the same letter y, then we can say these two expressions are equal to each other. I'm going to take these two equations and I graph them on Desmos, and what I notice is that they are parallel to each other. So if these two lines are parallel to each other, then the geometric interpretation is that there is no solution. Okay? That's one of the problems. Going on to the next one. Okay, here's another problem. We have, again, one equation where we're being asked if these two expressions are they equal to each other, and if so, when. So again, using the algebraic strategies, I undo. I add 5 to both sides. I get a 0 pair. I'm left with negative 2x equals minus 4x plus 7. Then I add 4x to both sides, right? Because I want to get all my x terms on one side of the equation and all the other constants on the opposite side of the equation symbol. When I do that, I'm left with 2x equals 7. As you can see, I undo, I divide 2 from both sides, and the actual work looks like this. 2x divided by 2 equals 7 divided by 2 implies that x is equal to 7 divided by 2. If you go to Desmos, I believe this problem is also on there, and what you should see is two linear lines intersecting at a coordinate point whose input is 7 divided by 2. It'll also give you the output, okay? So again, make sure you reference Desmos, the link for Desmos that I provided. A little more challenging problems that involve fractions and decimals. And so we start with this problem right here, 1/2 x minus 2 equals x minus 4. Now, I'm going to use this concept of fraction busting. And if you remember back for a few, I think it was in March, early March or late February, fraction busting means I want to eliminate this denominator. Excuse me. So how do I eliminate the denominator that's in this equation? Well, I multiply it by its denominator, right? And we're lucky here because there's only one fraction. And so there's only one denominator to choose, 2. 2 times 1/2 is 1. Boom, fraction's out. If I had multiple fractions, then I take the greatest multiple that they both share and multiply every term by that number, okay? And we'll get more practice with that later. Now, I multiply the left side and the right side of the equation, and I get 2 times 1/2 x minus 2 equals 2 times x minus 4. And when I multiply, I get 1x minus 4 equals 2x minus 8. I take away 1x from both sides, or subtract 1x from both sides, and I'm left with negative 4 equals x minus 8. I add 8 to both sides, again, isolating x, and I'm left with x equals 4. Geometrically speaking, because I have an input here, this is telling me that these two lines will intersect at a coordinate point that has 4 as its input. And you'll see the output when you, again, go to Desmos and look for these two expressions written as two separate equations. Okay, and I'll just add it here just so you understand what I'm saying. This is what I would graph. Y equals 1/2 x minus 2 and y equals x minus 4. This is what I graph on Desmos. Okay? They're going to intersect at a point where the input is 4, and the output believe it's 8. I'm not sure, 8 or 6, but it will give you, there's one intersecting point, and that means they do share a solution, and it starts at x equals 4. Okay. The next two, now we're dealing with decimals. Okay. So I have this really long equation of x plus 2 minus 0.5x, or 1/2 times x equals 1 plus 1/2 x plus 1. So the first thing I'm going to do is, can I simplify the left expression? And I can. Combine like terms. And I'm left with this. On the right side, I do the same. And notice that I broke it in parts. And I encourage you to do that. Break it down in as many steps as you can, just so you're sure and aware of any little mistakes that might happen if you wouldn't do it that way. Okay? I add 1 plus 1, combine like terms, and I'm left with this. Now, for some of you might see like, well, Mr. Cerna, these two are equal to each other. That means they're identical, and if I would graph it, I get the same line. So the answer would be infinite solutions, or all real numbers are solutions. That's correct. But I actually worked out the problem just for those of you that want to work it out and don't see it right here. Okay? So I'm going to use again the idea of fraction busters, but because I have decimals, well, since both decimals, all I got to do is move the decimal to the right one place for both, so that the decimal is gone and I'm left with an integer. I'm going to multiply both sides by 10. Okay? And it tells you my reasoning why. So when I multiply both sides by 10, 10 times 1/2 becomes 5, right? Because 1/2 of 10 is 5. 10 times positive 2 is 20, right? Remember, when I'm multiplying by 10, I'm going to distribute this 10 here. Equals 10 times 1/2, we know that's 5x, plus 10 times 2 is 20. Now, if you notice, I have a nice looking equation with integer coefficients and constants. I can go ahead and solve. Okay, I take away 5x from both sides, and then I notice that I'm left with 20 equals 20, which tells me all real number solutions. And if you graph this as two separate equations, you'll notice that they're the same line. Okay, and go ahead and practice that on Desmos if you haven't done so already. Last one. This was the last problem, I believe, and it's 7x times 15/100 equals 2 times x plus 6/10. Again, the idea of fraction busting, or in this case, eliminating the decimal. Notice that this is tenths, this is hundredths, right? So I'm going to multiply by 100 because this 100 is going to eliminate this decimal. Okay, and when I do that, it looks something like this. 100 times this term, 100 times negative this term equals 100 times this term, 100 times positive this term. Okay, so I'm left with 700x minus 15, because it moves the decimal to the right two spaces, 15, equals 200x plus, and this is 60. Why? Because it moves it 2 places to the right. So anytime I have an extra space, I'm going to add a 0. Okay, now that I have this equation the way it looks, yes, these terms look the coefficients look big, but that's okay because I have a calculator. We can work through this. It's better than playing around with decimals. If you like decimals, then you don't have to do fraction bustings. Go ahead and solve with the decimals you're given. We'll still get the same answer. We should get the same answer, I should say. Take away 200x from both sides. I'm left with 500x minus 15 equals 60. I add 15 to both sides, and then I undo multiplication by dividing both sides by 500. And at this point, I'm going to go ahead and use a calculator. I use Desmos, and this was my fraction. What does this say? It says, hey, these two weird looking expressions do have something in common. They're equal to each other when x equals the fraction 3 divided by 20, or 3/20ths. Okay, and this one was also included in the Desmos answer sheet. It's the last one. I think it was problem 7. It says on the folder. If you click on it, it'll show you the intersecting point with the output, and then you have your coordinate. Okay, and these are the solutions to some of the problems you worked on. Make sure you go over the Desmos link I provided and review the answer sheet that's also included. Okay, till next time.